It's really exciting to be back here at Westport. It's sort of kind of like a second home for me, guys. So I want to thank you for inviting me to come back and talk to you guys. Before I get started, I want to thank a couple of people that came by and brought some of their rockets too. So we've got some other amateur rocketeers that are in the audience, and it's really exciting to see some of the rockets that they brought. And still know that I still have the biggest rocket in the room. That's all right.
We got a trumper here. I
just had to go there. So, anyway, for those that are not familiar with rocketry or high-powered rocketry, I just wanted to kind of give you a little bit of a presentation about the experience that I had going into high-powered rocketry. I'm sure probably many of you have probably worked with small model rockets, the Estes class rocket, what's considered the model class rocket, probably in school or in your youth. And so what I wanted to do was kind of show you what the scaled up version of rocketry looks like, and then just kind of give you a little bit of a primer as to how you can actually approach going into this hobby. And so I'm going to kind of couch it in the experience that I had doing this high-powered rocketry in the context of a high school club that we started at the museum. And we have a club, and I was searching for a name, so we call ourselves Space Club. And the Space Club does high-powered rocketry and all sorts of other space exploration-related kinds of experiences. So this is kind of how I learned how to do this. So a year ago, probably about this time, I knew really nothing about high-powered rocketry, and it was a steep learning curve. There's a very steep learning curve in terms of getting from the small rockets, model class rockets, to the high-powered rockets. And so I just wanted to kind of at least give you a little primer as to how that works. So first off, I want to just kind of start with a little bit of history. And for some of you guys that are in the room, some of these names are actually kind of familiar. This is really where rocketry actually, as a hobby, starts to really become part of youth experiences as they want to look at and explore STEM-related careers or STEM-related kinds of hobbies. So in the 1950s, there was this urge on the part of young people to be part of the space program. And one of the things that they really wanted to know was rocketry. But there really wasn't any safe way to do rocketry. So the kinds of rockets that these kids were playing with were nothing short of pipe bombs, basically. So this is the kind of this is where kids are actually starting. So they're attempting to really kind of learn the mechanics and the physics of building rockets, really almost through trial and error, trying to actually capture sort of this amazing moment in history where the dawn of the space program and dawn of the space age is actually starting. Enter this guy called Orville Carlisle and Robert Carlisle. These two guys are brothers. One of them is a professional pyrotechnician, and the other one is actually a model airplane enthusiast. And so they see in this space that there's an opportunity to be able to really teach rocketry in sort of a safe way. So they kind of invent a product, a model rocket. And so they actually patent this product. And in 1954, they get this thing accepted, or at least patented in 1958, but they filed it in 1954. And this is sort of the very first model rockets. What's amazing about this model rocket isn't just the rocket itself. It's what it had was a rocket engine that was safe to launch, and that was electrically ignited, and bears the resemblance to many of the modern hobby rockets that you'll see with the main charge. It had a way to deploy a parachute, all those kinds of things.
Is that a solid engine?
And that is a solid engine. It was actually black powered. And so you have to understand that in this time period, the context in which these model rockets are being designed is still within sort of fireworks. Okay, so that's the closest that these guys are working with in terms of a model. And what they're trying to do is just trying to take a firework and try to convert that, back engineer it, and turn it into a hobby rocket. So that's kind of what's happening here. Around the same time, though, there's this other guy. His name is Harry Stein. So Harry Stein is actually a rocket engineer, and he works at White Sands Missile Range. So he's actually firing not rockets; he's actually firing missiles. Okay, so this is the closest. In terms of what kids are thinking of when they're launching rockets, is actually missile systems. So what's happening is that this guy somehow gets he basically becomes known to the community of young rocket engineers, and they start a correspondence with him at White Sands, writing letters to him, asking him how to make their rockets safe, how to actually launch them, how to actually really start into the hobby of amateur rocket making. And these are all young people that are trying to do this. He writes an article in Mechanics Illustrated, and basically in this article he basically lays out, okay, if you're going to do this, you want to really launch rockets, these are the things that you really need to consider in terms of making sure that you actually launch these rockets safely. And so what happens is that the idea that actually there's a standard, a safety standard. This is starting to gel around this time with this article and all of the correspondence back and forth between these young engineers, really, and this rocket engineer that happens to be at White Sands. One of these articles actually gets the attention of Carlyle brothers, and so they decide to write him. And there's actually, you can actually get this online, all of the letters that Carlyle and Stein exchange, where they talk about, where Carlyle is basically saying, we have a product that we would like to introduce into the market. Would you be willing to test it for us and help us to create a hobby out of this product and out of amateur rocketry? And so Carlyle actually sends a couple of samples of his rockets to White Sands to get Harry Stein, and Harry Stein actually does some testing and tests out the rockets and actually writes an article saying, wow, this is a really cool product. You should consider thinking about, making rockets that are like this. So this was really important. Carlyle actually got fired. Stein actually got fired from White Sands because around 1957, you know what happened? The big famous satellite that actually went up in Sputnik. That's right. So what happened is that Sputnik goes up, and somebody from, I think it was a Mechanics Illustrated, actually asked Stein for a quote, and he actually sent them a quote about satellites, and that quote actually was not flattering to the United States, and so he was actually fired the next day. So here he is, Stein is without a job. I know, seriously. So Stein was without a job, and he calls up the Carlyle brothers, and they decide, let's start a company. And so the company becomes Model Missiles Incorporated. Okay, so Model Missiles Incorporated is formed. And then Stein decides to create an organization, a national organization, to promote hobby rocketry. And he calls it the Model Missile Association. Now, I have to tell you, it would later become the National Association of Rocketry because no parent wants to send their child to a hobby called Model Missile Association.
That's a great name.
That is an awesome name for getting kids excited. The Boy Scouts are going to jump right on board for that one. Not going to happen. Okay. Now, what happens though is Model Missiles Incorporated, they start announcing that they have a product, their one-use rocket engine, a safe way to actually do rocketry, into the hobby of rocketry. Big problem is that Model Missiles Incorporated cannot handle the demand for rockets. And so they are starting to really struggle as a company to be able to handle the just incredible demand by young people all over the United States wanting to get into this hobby. And so if you're at that time period, late 50s, early 60s, you want to get into the hobby, you're calling this company and you're still waiting for your rocket. Okay, so this was a real problem. And so what happens is that Model Missiles Incorporated decides that they really need a supplier. They go and get the Denver, I guess the Yellow Pages or White Pages, whatever it was at the time, and they look in the fireworks section of the Yellow Pages, and they find the first name that's listed in the fireworks section, which is the Estes Company. Okay? So Estes is actually a fireworks company. Okay? So they're a fireworks company. Now what happens is that they're approached and they're asked to somehow come up with a way to mass produce these rocket engines. Okay, this was the hard part, to really mass produce the rocket engines. And the guy that really takes up the mantle of building a system, of building a machine that can actually mass produce these things, is the son of the founder, Vernon Estes. And so Vernon actually looks at the problem, and he called up an engineer and told him, I would like to be able to quick load cartridges of black powder and get them out in a machine that can load them as quickly as possible. And the engineers in Colorado basically said that's just not possible to do. And the problem was that they were looking at using electricity to do this. And he's coming up with this idea of a pneumatic plunger system to be able to quick load all these rocket engines. And so what Vernon does is that on his own, he builds the machine that is able to mass produce the rocket engines. And this transforms everything. The name of the machine is called the Mabel 1. Okay? And the Mabel 1, if I'm not mistaken, Mabel 1 was capable of actually producing about 5.5 rocket engines a second.
Jesus.
So wow. that changes everything. Yeah. That changes
everything. That's a lot of demand.
That's a lot of it. The demand is there, but they need the machine to meet the demand. And so that will happen. Because you can build the rocket, you can make the rocket, the kits, you can make these kits and you can build a rocket. The problem was that you needed the rocket engines, the engines, because the rocket was reusable, the engine wasn't. Okay, so that was a one-use kind of a thing. The problem is that MMI, through bad decisions, kind of happens, sort of like Netscape, they go out of business, they go out of business, and Vernon sees an opportunity, and he decides that he's going to really go into the rocket engine and rocket kit business, and he pulls out of the fireworks business and exclusively starts building rocket engines and rocket kits, and he becomes a hero among young people of that generation for being able to literally create this hobby and meet the demand for kids. So I was talking to some people earlier. They were telling me that they had old catalogs where you can get all these different rocket engines and rocket kits and all this stuff like that. This is all a legacy of Vernon Estes, and he's still around. He's actually still around, pretty healthy. He does end up selling his company. But he becomes really famous for really building the hobby. And here he is with Mabel 1. That's actually him. They took a picture of him as he's trying to kind of fine tune and work with Mabel 1. Mabel 1 did hurt somebody. Yeah, there were a couple of accidents, but eventually though he was able to perfect it to the point where he was actually able to produce a number of engines for the market. The story is that Mabel 1 did end up kind of like in storage, and he was out of the office for some time, and somebody decided that looks like scrapped it. Yes, so he comes back and he finds out that Mabel 1 is gone. Yeah, so that was kind of a bummer, So he was very upset. He's kind of upset about it because this was like a piece of history. So Mabel 1 is actually probably in somebody's lawn art or something. So that's unfortunate. Let's talk a little bit about model and high power class rocket engines. So for probably the better part of the 50s, 60s, into the 70s, and probably into the early 80s, model rocketry is in what's called a model rocket class. And we're going to talk a little bit about the engine types and how you get from a model rocket class into the high power class of rocket engines. So when we're looking at a model rocket engine, a basic model rocket engine, this was the brainchild of Carlisle and really mass produced by the Estes company. And you have this casing, basically, and on the bottom of the casing is our nozzle, and it could be clay or some other material. We have this charge, this propellant, it's called, and we have to actually officially call it propellant, okay? And that propellant in there is what provides the impulse or the thrust for the rocket. There is a little bit of a delay charge. That delay charge is so that at apogee, it gives you a bit of a delay before the rocket deploys your parachute, okay? And so the orange, that red section up there, which says 5, that's called the ejection charge. The ejection charge is actually a secondary pyrotechnic that actually ejects the nose cone and deploys your parachute. This was a brainchild of Carlisle, to be able to create in a complete system the thrust that you need to launch your rocket, the delay at apogee, and the charge to be able to deploy your parachute. So this is a pretty neat system, and Estes is able to quickly mass produce this.
So what's igniting these things while it's up in the air? Is it,
It's a special. I wish I knew what the kind of propellant it was.
I see it was black powder.
Yeah. We use the propellant is for the main charge. That's a black powder. And we use, at least in high-powered rocketry, we actually use black powder too. There are other composites that are used when you get into the aerotechs are composite. Then you get into really high-end engines. Those end up using we use composites, because if you pack the powder not the right way, and if there's a little crack in there, you can actually blow up the engine. So this is dangerous stuff. So this is Cato. That's right. And it's like the name of the club too.
Yeah.
So we call ourselves Cato. So right here is at least a thrust profile of a typical rocket engine. And by using this thrust profile, we are actually able to classify the rocket engines by impulse and average thrust. And so the way that SDs decides to kind of create this grading system of ever more powerful rocket engines is they take the rocket engine, they'll test it, and what they'll do is they'll put it on a force meter to measure the amount of thrust that the rocket produces over a certain amount of time. So you can see that when we ignite the thing, there's an enormous amount of thrust that's produced, and eventually, as the powder is burning, you'll see that the thrust levels off, and eventually at main engine cutoff, when MECO, main engine cutoff, you'll see that thrust decays and comes down, and then there's a delay time, and then the delay charge will actually rise. So when you see a rocket engine, there's a kind of a code that's on the rocket engine itself that tells you a lot of information. And so you'll see the letter, number, dash, number combination. The first letter is basically telling you what's called the total impulse. All right? And basically what that is, mathematically, is just the area under this entire curve. Okay? So that's what's called the total impulse. It's basically the amount of thrust times the amount of time that the thrust is actually firing. And so that is in units of what we call Newton seconds. Now the thing is that you'll see at the side there that 2.5 Newton seconds for an A engine, 5 Newton seconds for a B engine, C is a 10 Newton second impulse. These numbers are not exact. And in fact, somebody actually did a study of all of these engines, and they were far from being in this exact number for an impulse. But what these numbers do tell you is that if your impulse goes above that number, you are in another class. All right? So if your impulse goes above a 5 Newton second, you're starting to approach now the C engine class. So that's how we determine what class the engine goes into. The number next to that letter just stands for the average thrust, okay, in newtons. So this kind of tells you if you have a C6, it gives you the information that it is a maximum 10 Newton second class impulse with an average thrust of 6 newtons of force. Okay? And so on a force meter, you can actually measure all these things. Then the last thing that you see is a number, and that's the delay time. And that basically tells you how long that delay charge is going to fire after the engine fuel has been exhausted. And so this is important when you are actually determining when you want the parachute to deploy. And so in every one of these engines, you can see the code. So I've got an A64. So basically the A is telling me that it's in the 2.5 Newton second range impulse. The 6 tells me it's got an average thrust of 6 newtons. And then on top of that, I've got a 4-second delay before the parachute deploys. Now, one of the things that Estes did was that he actually, because he did fireworks, he packed in there a little smoke in the delay charge, or the ejection charge. So that way, when the rocket goes up at apogee and it deploys the parachute, there was a little smoke bomb, and that allowed you to actually find it. Because nothing, you look at these rockets go up and you're like, oh no, where'd it go? I don't know where it is. Happens all the time. So especially when you go higher. So that's sort of the idea that we're being able to kind of quantify the power of some of these rockets. So when you are working in what's called a model rocket class of rocket engines, your model rocket class goes from about 1/8 of an A, which is these little tiny things. These are these really baby rockets, You can go up to the A's and B's, which rockets like this can take an A engine and a B engine. And this is probably most kids' first start with rocketry, is rockets in this class. And if you want to really go all out, then you can start getting into the C and D rocket class, and then up until around G. Now, the thing that's important, though, is that up to around here, to the E engine, up to D, rather, this is called a low power category of rocket engines, okay, in rocketry. So if you're doing anything from eighth of an A up to D, you're low power, you're pretty good, you're getting started. Once you get into the D engine range, or the E engine range, then you're in the mid power range, okay? Rockets are going to be bigger, they may be slightly heavier, and E, F, and Gs, they are going to be somewhat regulated, but not very much. So it turns out that even if you want to, you can actually go to Hobby Lobby, which I did in Milford. You can get an E engine right off the little cards there. So the F engines and G engines get to be a little bit bigger, and then you start looking at this right here. So this is about as big as the model class rocket engine is going to get. So this is an Aerotech engine. So this goes into a fairly large rocket. To do this. But if you're a kid, you can still do this stuff. So that's pretty good. Fortunately, you can't get into this if you're under 18. Okay, so this is where we get into the high-powered rocketry class. So this here is telling us that at the H and I scale, which we're looking at roughly every letter increase is a twice impulse increase over the letter before it. Mm. So this is an exponential increase in power as you start getting higher and higher in your rocket engine class. So right now in the level 1 category of high powered rockets, you're in the H and I. And so that rocket right there, when I first started firing this dude, that white rocket over there, that had to take an I engine just to get me into the level 1 certification. And if I put an H engine in there, it just wouldn't be enough to get it off the ground really high. So that was probably with the I engine on that thing, and that was about 12 pounds, which is pretty heavy. That guy flew up to, I think, about 1,000 feet, 1,300 feet, something like that. So that kind of gives you an idea of the kinds of altitudes we're capable of, and even that is actually kind of short. That's not as high as what some of these rockets are capable of. When you get into the J, K, and L engine range, then you're in what's called the level 2 category. And so you will need a certification to even launch and buy these kinds of rockets. And then, if you really want to go nuts, go into more money. It's more money, yeah. And so just the I engine alone was like one-use I engine was like about $60, $60 or $70. Yeah. That's okay. Yeah. So like you need another hobby to blow money out. Okay. So the M, N, and O range, then you were in what's called the level 3 rocket certification. Beyond that,
who's certified?
Who does the certification?
I'll talk about that. Yeah, there's actually an organization.
How big would a rocket with like an O engine be?
You know what? I think they're about 8 feet. I've seen the small ones are like 8 feet. They get up to about 15 feet tall.
Jesus.
What's the altitude limit on that?
What's that?
What's the altitude limit on that?
Depends on the FAA clearance.
Yeah.
And so with an FAA clearance, I know if you go out to New York, they have a big festival out there called Earth. I don't know what it stands for, but it's like a mega
that's in Goshen.
In Goshen, thank you. Yeah. They fly out there with an FAA clearance of 18,000 feet.
Oh my gosh!
So this is a great
How do you find something like that?
What's that?
Once something goes up that high, you've got no chance of seeing it again, dude.
There is. There are ways to get it back.
GPRS on it.
Yeah, it can.
Some have GPS and some have.
And there's also a way called dual deployment. There's actually, and so I'll talk about that as well. So this particular rocket, we were able to get it back. Of course, it's only like 1,300 feet. But if you go a little bit higher, there's actually a way to get it back so it doesn't actually if you deploy the rocket parachute at apogee, or 4-second delay or 3-second delay,
It's gonna take forever.
it's going to take forever. Yeah, 18,000 feet up, you're going to be traveling miles to find this thing. So we actually have a way for it to drop down and then deploy the parachute. And so we have technology to be able to do that.
So what is one of those engines cost?
I think it's like the hundreds of dollars.
Yeah.
Yeah, like $300 or $400
For one flight.
Yeah, and so what happens is that this gets expensive. This gets really expensive. So right now there are actually products where you buy the cylinder and then you load the engine propellant into the cylinder.
That saves you money.
And that saves you a little bit of money. Yeah, but this hobby is by no means. This is not a cheap hobby. This is like when you're in the high power class. Like for example, that I just saw today, Macau Rocketry had an 8-foot level 3 class rocket for like $1,000. That's just a kit.
That Patriot cost me 100 and change.
Yeah. That black ramp was probably close to 280. And it comes as a kit, so you gotta put the thing together. And the worst part about it is that the instructions are incredibly cryptic, and they don't tell you a whole lot of stuff. So you have to actually have someone that does rocketry to help you build this thing, which I can tell you where to go.
Go to your house.
Outdoor club. Yeah, we got another kit we got to build. Which is another black ramp. And so over here, just to kind of give you an idea in terms of how big a field you will need for some of the model class rockets, and then imagine what an M, N, or O class rocket is going to need in terms of, you're going to be out in the desert. You're going to be out in the middle of nowhere. So even for the G class rocket, you're going to need at least a field of about 1,000 feet in diameter, or 1,000 feet on the smallest rectangular side. So we're talking about you need a lot of room in order for you to safely launch these kinds of rockets. When you get up to the H and I class, you're going to need several thousand feet. But there are ways to be able to actually get that rocket to come down very close to the launch pad. And I'll talk about that in a little bit. So let's talk a little bit about the sport rocketry, the hobby of sport rocketry model in high power class. So what is sport rocketry? So there's a great quote that I found. It's aerospace engineering in miniature. Okay? And so when you are actually a member of the sport rocketry community, you are doing rocket science. This is not no lie. You are literally doing rocket science. You are doing rocket science in miniature, but all the principles of rocket science apply even at that scale. The center of pressure, the center of mass, the aerodynamic forces that are acting upon the rocket, all of those kinds of things. We've gotten to the point where we actually can simulate rocket launches on a computer, and you can actually design a rocket of any type that you would like and actually simulate the aerodynamics and flight dynamics of that on a computer to determine whether or not you're going to be launching a safe rocket. So those are some of the things that the hobby has advanced to, which did not exist back in the 50s and 60s. You basically just kind of eyeballed it and go, oh, that thing looks good, let's try it. That's how it was. So, but sport rocketry though is great because it's a rather inexpensive way for young people to learn the principles of rocket flight. So many kids that come into our programs at the museum, if we're doing Space Club, we're doing rocketry, and we're actually giving them the opportunity to actually fly rockets. The sport rocketry claims we've got about 12 million flights per year. This actually comes from the National Association of Rocketry site. It's used by well over 25,000 schools in the U.S., and it's very important. It's actually permitted under federal and state law. Okay? And we have to actually make the distinction between sport rocketry and fireworks. Okay? Sometimes people confuse the two, but they are different. And it took a long time to actually make that difference. And in fact, just recently, I think in 2009, the National Association of Rocketry actually had to file suit against the Bureau of Alcohol, Tobacco, and Firearms because the propellants we were using were going to be categorized as an explosive, and then all of a sudden that would have killed the high-powered rocketry community. So a judge actually ruled in favor of the National Association of Rocketry, just to give you an idea. Yeah.
Can you mail these around? Can you mail the engines?
Yes, you can. Yes, you can. So that brings me to I'm going to talk about sport rocketry, and then I'm going to talk about the legalese of rocketry, just to give you an idea of all of the legal underpinning to actually make it possible for us to be able to launch these rockets. So, and I'm going to talk a little bit about what a sport rocket is. It may seem pedantic, but it's important because this is what determines that you actually are doing rocketry and not shooting fireworks. Okay, so that's the thing that's kind of tricky here. So, for example, right here, a sport rocket is reusable, lightweight, it is non-metallic flight vehicle. It is propelled vertically. Okay, so that's pretty important. In fact, we have a range of from vertical of about 20 degrees that we don't launch our rockets anywhere beyond 20 degrees of vertical. Okay, so that's pretty important. Okay, we use an electronic igniter. The reason why we say this is because if your rocket has a fuse, okay, if you lit it with a match, that's not a rocket. Okay? Now you've done something different. Now you've done something illegal. Okay, so you actually have to have an electrical ignition system. Okay, so if anybody was using a rocket fuse or something or lit it with a match, you were doing something no. Okay. It also includes a recovery system. Okay, and it is actually now divided into two classes: a model class and a high-powered class. Back in before 1980, there really wasn't a high-powered class of rocketry. So this is actually fairly recent. This whole new age of really high-powered rocketry. In terms of the legal protections for you to be able to launch model rockets, so we're now still in the model rocket class. It's actually regulated under what's called the National Fire Protection Association Code. And it's code number 1122. Now, why is that important? It's important because the fire departments all around the United States, they apply these National Fire Protection Association codes. So that way a fire department can't come up to you and say, you're doing something bad or illegal. It's okay. Okay, it's okay. As long as you follow the safety guidelines and use the safe products for model rocketry. You're actually exempt from FAA air traffic control, which means that you don't have to tell the FAA you're launching a model rocket. That's fine, you know. Not that I would do that near an airport; that would be bad. But you know, you don't have to call up your local air traffic controller to let them know that you're going to be launching these rockets. It's also permitted safe for children under the Consumer Product Safety Commission. Okay, so that means that yes, young people can actually play with model rockets. It's permitted to be shipped by the Department of Transportation and U.S. Postal Service. Okay, so as long as the rocket engine is labeled as rocket engines, okay, it can actually be packed up and shipped, and that's how we actually got our package of rocket engines today. So we actually have that. So it's allowed for you to ship, and then on top of that. And is not subject to regulation or user licensing by the Bureau of Alcohol, Tobacco, Firearms, and Explosives, okay? Because technically, you are launching a model rocket. You are not launching an explosive. You know, it's not a missile. That's why we had to change the name to the National Association of Rocketry, not launching missiles with kids. And of course, how wholesome can it be? You're being endorsed by the Boy Scouts and 4-H Club, and of course, NASA. Okay, so NASA wants you to launch rockets, which is fantastic. Okay, this is for model rockets. Remember, that goes up to G class. Oh my gosh, I want to go into high-powered rocketry. Well, now we got some more regulations now. This is where it gets a little more complicated. So right now, though, with high-powered rocketry, now you are no longer under code 1122. Now you are under code 1127, okay? And under code 1127, there are all sorts of procedures and safeguards that you have to ensure following, because high-powered rocketry, the kinds of firepower that you're dealing with here is much higher than model rocketry. It is not available to people under the age of 18. Okay? So it turns out that for like a model rocket certification, like a level 1, a level 2, and a level 3, you have to prove that you're 18 and over to get those certifications. Okay? There is a special class for people that are under 18 to launch rockets under adult supervision. But in order to actually get a level 1 certification, you got to be over 18. So that's the other way. Flights are subject to FAA air traffic regulations. So when you are launching a high-powered rocket, you do have to alert air traffic control that you are actually launching a high-powered rocket, because you could actually fly right into air traffic. So this is where it gets a little, you know, we have to be very careful. And you can only purchase large motors if you can show that you have a certification to actually purchase those motors. Okay, so when you get into the H class and I class engines, you have to show that you've got a certification recognized by the National Association of Rocketry, or AAA, that allows you to actually purchase those rocket motors. So you know, you'd love to go gangbusters into rocketry. You kind of understand that there's a a couple things that you have to kind of keep in mind, and not least of which is legal liability if something goes wrong with your rocket. Okay? So that can happen. So, you know, if that thing came down 1,300 feet and a parachute were not to deploy, you're in trouble. You're in serious trouble. You are in serious trouble. Your home, the hoopty that you drive to work is going to be in some serious trouble. Now, if you join the National Association of Rocketry, though, you are covered as long as you did everything under their safety policies and guidelines. You are covered up to $5 million. Okay?
Wow, by them?
Yeah.
Yeah.
Really?
Yes.
So you must pay a fee to belong to that.
Correct. That's right. So you pay a fee. And you're a member of the National Association of Rocketry, and under their membership, you get that blanket policy.
Is there a serial number on that?
Nope. Nope.
So they just have to physically know that you did it.
Correct. That's right. So what they physically know that they did it because it was witnessed by those who have a level 1 or level 2 certification.
No.
So there's an entire process I'm going to go to tell you, okay, how can I launch this thing again with that level 1 certification? Okay. So that tells you a little bit about the legal considerations. Let's talk about how do I get a level 1 certification. Okay. So you decided you're going to buy the rocket, right? Which you can do. You can just buy the rocket kit, and you don't need a certification to do that. You may be wanting to buy your rocket so you can get the level 1 certification. Now most of the time when people get the level 1 certification, they go for a rocket like this. And I said, screw that, I'm going here. That's what I did. Okay, so, that's right. I was not going to go, so I got high school students, how bad could this be? That's going to be sick, that'll be fine. All right, so and the reason why I did this was for a couple of reasons, and I'll explain and elaborate a little bit more later. But the reason is that nose cone is a perfect size to put electronic payloads. And so what we're hoping to do with our high school students is we want to equip that with a payload that's able to give us telemetry, and that telemetry is going to have a radio, and it's going to radio telemetry to the ground. Okay? And so I'm going to talk a little bit about that project and what we're trying to do with that. So I needed a rocket to do this. I needed something with a big enough payload and a big enough rocket to be able to make it interesting.
You just put a radio in there, or you?
Yeah.
GPS?
It's going to have a GPS, it's going to have radio, and it's going to have it's going to have a main board that's going to handle transmitting and receiving commands, and then they're going to have student boards underneath that are going to have on their deck all of the sensors, accelerometers, and all that stuff that the kids will be on laptops and radios, and they'll be able to get all that data down to the ground.
You can do like APRS with it too, or not?
No, we're not going to go that far. But the next thing that we're going to do with our club is we're really thinking of doing high altitude ballooning, and that we're really going to do APRS.
Well, you had that before.
We did, yeah. So we did launch ours back in 2015. So we're going to piggyback on that, and then we're going to work towards having the students actually build that payload. But we got the tracking nailed down, so we're in pretty good shape.
So how much is that going to add to the weight of the rocket?
So that's a good question. You're probably looking at another 2 pounds.
Are we doubling it, or?
What's that?
Is it double the weight or half the weight?
Of the rocket?
Yeah, how much are you adding to it?
Oh, so the rocket itself is probably around 12 to 13 pounds.
Oh, it's that much?
Yeah. So I'm probably going to add about another pound, if that.
That's not
they're very
bad.
small circuit boards, integrated circuit boards. They're going to have probably the heaviest thing is going to be the radio.
What's it made out of?
That's made out of fiberglass. And the company that we bought it from, Mad Cow, those parts fit like butter. I mean, they read every part, like the fit is perfect, absolutely perfect. So in terms of a kit, this is called the Black Brant 2. This is a very high end kit production. There are no loose fitting parts on this anywhere at all. And we over-engineered this thing because we had university students helping me with this, and they just naturally
What's
over
the cost?
So this is about $280 for the kit. Yes, but that's just the kit. Then we have to add another set of stuff to, like parachutes. Doesn't come with parachutes. We had to buy Kevlar cords.
How much is the parachute?
So the parachute's probably in the 80 to 100.
Wow.
Yeah. The eBay alone, the electronics bay, to be able to do all the pyrotechnics, to be able to deploy two parachute systems on command. That thing alone was that's like a $100 chip, but you can get them. Some of them are even more expensive. There's one that does exactly what we're going to do with the payload, that's like a $300 chip, but it actually radios transmissions down to the ground. So you can actually have like a little handheld antenna, and you can actually get all the telemetry. Yeah.
So to put it together and actually fly it, how much does it all cost?
Yeah, good question. So this particular rocket, you're looking at 280, probably 380. So it's probably a good $600. It's probably conservative. And that is, this particular class of rocket is probably way more than I needed to get the level 1 certification. And so in fact, one of my other colleagues, she's an engineering student up in northern Connecticut, she was able to get her level 1 certification with a rocket half that size of the US Army one. Okay. So you can get that level 1 certification with a much smaller rocket. Yeah.
What do you use the Kevlar for?
So the Kevlar is a cord. Yeah, because it came with a cord, and we just said, we don't like this. We're just going to chuck it. So we did some personal modifications to this rocket that weren't part of the plans. We actually over-engineered everything, which helped, as you will see towards the end. So I'll talk about that.
But that's it's a $600 investment, but you get most of that back, right?
Yes, that's right. So it's reusable, and the other thing that we can the thing that's expendable is the rocket engine. So you can use single-use rocket engines, or they have these types of rocket engines where it's just a pipe, and then you just reload it with propellers. Yeah, and so that's another way to go. So there are a number of ways to kind of cost cut, but it is still an expensive hobby. Yeah.
Is that a metallic pipe or?
No, it's
something
fiberglass.
else?
Yeah, it's fiberglass.
It's a fiberglass pipe?
Yep.
So you're only gonna get so many shots out of that before that'll.
It's tough. It's actually pretty tough. I was surprised because yeah,
The Army one, that's not fiberglass, that's tubing.
yeah,
Paper tubing,
yeah. Go ahead.
How do you find the nose cap? Is that hinged, or do you just have to?
It's slid on. Yeah.
I mean, it's part of the rockets, like the explosive thing. What's the nose cap?
Yeah.
Explosive,
So the
right?
nose cone, you mean?
The nose cone.
Yeah. So the nose cone is actually the slip fit, but because the speeds of these rockets are so fast, if I were just to launch the rocket like that, the speeds would actually, the aerodynamic forces would actually start to slide the rocket parts apart.
Jeez.
Because these, some of these things can go Mach 1.
Yeah.
And so what we need to do is we drill these little holes into the rocket when we've got it ready to go, and we slip in there these little plastic screws that are called shear pins. So they hold the rocket together, but they're not so strong that when we blow a little bit of black powder inside, the shear pins will break to let the nose cone deploy the parachute. Okay. So all these parts are, there's like one part that's held by a machine screw. The rest of the parts are actually kind of slid together and held by what are called shear pins. They're small plastic pins.
So does the nose cone typically fall close to the rocket?
What's that?
Because I mean, the presumption is that you'd be able to reuse the whole kit. And
Yes, correct.
so does the nose cone fall close to where the rocket
Yes,
falls?
because they're all attached by cables. They're all attached by Kevlar.
Oh, okay.
They're all
The whole thing.
Yeah,
Now,
yeah.
there are kits though.
Shot cord.
Yes, it's called the shock cord. That's correct. Yes.
Yeah.
So the little kits have like a little bungee shock cord. We use Kevlar on ours. Now there are some kits where they do come down in two pieces. So you have the booster stage and then the nose cone comes down. So it all depends on the kit. But ours, all three of those pieces are protected by Kevlar cord and really beefy eye bolts, and not the regular eye bolts you can get at Home Depot. We're talking about like it's a whole one solid eye bolt piece. So for your level 1, you need to build and launch your high-powered rocket with an H or I engine. We choose I because we just want to do that. You actually have to make sure that your rocket passes inspection. It has to be witnessed by a certification team. So you actually have to have 2 people that actually specifically witness it that have a level 1 and level 2 certification, and they can sign off on that as a committee. And then, this is pretty important, it actually has to survive the launch. Okay? So if it's broken when it comes down or lands in such a way that it breaks, you don't get your level 1 certification. So the thing has to be beefy enough to hold itself together. Yeah, it can happen. Yeah.
Now, with all these regulations, I can see people saying, screw that, I'm just going to go out and do it in my backyard.
Yes, that's right. And then they get sued. Yes, because
They get caught.
They get caught, exactly. Yeah, you can set a field on fire. And we actually saw that happen. We saw that happen. Yeah. So you can set a field on fire. So nothing it makes people at the high-powered rocketry amateur club more nervous than having to run out into the field and stomp out the fire from the rocket.
Most of the clubs have fire extinguishers.
Yes,
around,
it's
around,
yeah, it is. This
You
is
have to.
you have to, yeah.
And then there's a certain motor they have. They're called sparky motors.
Yeah, you can't have those. Oh god,
And
yeah.
they take off. They shower.
They shower sparks
Yeah.
and flames.
So they'll tell you no sparky motors.
No
today,
sparkies.
it's too
Yeah,
dry.
yeah.
Fun to watch.
Oh,
yeah,
they do. They don't stop selling
on
them.
YouTube and look it up. You'll find it.
Oh, yeah. And then you have to submit your paperwork. When you do, you get this. Woo! There it is. Yeah,
Ooh, a
little-
pin.
Congratulations. You get a little pin.
Yeah,
good. Tiara, man.
Yeah, so that's great. You put that on your little flight suit, you know, you feel big about yourself. There you go. That's it. That's what you get. That's awesome. Level 2, though, gets a little bit more complicated. So with a level 2 certification, still minimum 18 years of age, you have to be a current holder of a level 1 certification, and you actually have to pass an exam, okay, with a score of 88, and I think it's like 90 questions or something ridiculous like that. So it's pretty nasty. Okay. Then you have to get a site with a FAA waiver. You have to build and launch a high-powered rocket in the JK or L engine class. It has to meet a pre-flight safety inspection. It has to be witnessed by a certification team. And of course, after flight, it's got to be in one piece. And then you submit your paperwork.
What's the FAA waiver?
It just lets the FAA know that you are launching a rocket.
That this is a spot that's
That's right. On the
I'll
spot.
give you how many feet.
That's right. They'll give you a ceiling too. They'll say,
Yeah.
okay, you can launch up to 2,000 feet. This is your FAA clearance to do that. And so that just they have to actually do like what's called a notice to airmen. So that way, if any dude is flying their airplane around
Yeah,
there,
we had problems with that. When they do that, these pilots, when they go to flight school, these private pilots,
yeah,
they'll know that there's a launch.
Oh, that's
and they
wonderful.
purposely fly around.
yeah, just to
Like
check
flying-
it out, right?
Yeah,
Yeah, that's
check it out.
awesome. No, that's about like the boats that are at Wallops watching.
Right.
The wayward boats.
Yeah, exactly. Yeah, you can shut down the whole rocket launch. Yeah.
Just one boat, and I love though. They all sometimes they show you the people in these boats that are just not even aware that Kennedy Space Center is a launch site. It's like, you own a boat here and don't know that?
Spaceport? What spaceport? Yeah. So that happens. Here with the level 1,
Just tell them
there is a whole mess of paperwork you have to file in order for you to get this level of certification. So one of the things that's kind of important about the level 3 certification, is that the rocket has to be substantially built by the flyer. What does that mean? That means for level 1 certification, you can help with the building of the rocket, but you can still get a level 1 certification just by launching the rocket. Okay? So as long as you safely launch a rocket and can demonstrate you can safely launch a rocket in the level 1 class, you're good to go and you can get a level 1 certification. Not so with a level 3. You actually have to know that you can build a rocket. Okay?
No kit.
Yeah, no. Well, you can build it with a kit.
Yeah.
You can get a level 3 kit. But the important thing is that you built it. You have to put the engine mount, you have to put the fins, all that stuff.
And how much is that kit?
Oh, that is about $1,000 right there.
Yeah.
Definitely.
Yeah.
Yeah.
Okay.
That's it. But then you become part of the level 3 certifying committee.
You get another pin?
You get another pin.
All
And another flight suit.
Yeah, another flight suit. Yeah.
There you go.
And then it has to there's this thing called the Level 3 Certification Committee members. So these are like really highfalutin members that actually have to certify your flight. And you need 2 of them to actually be able to file the paperwork with. You don't need the level 3s to actually witness the flight, but you do need the level 3s to actually certify that this rocket is safe for flying. So there's a whole host of things that you have to do. But when you do all that, you can get yourself that pin, which is awesome. But I do recommend that if you are really interested in getting into the hobby, is to join a rocketry club. Okay, that is the best thing you can possibly do. Primarily because of the institutional memory and knowledge that's in those clubs. Now, the club that I personally belong to is the National Association of Rocketry. Fantastic. You get this really cool snail mail magazine. Awesome, so it doesn't kind of a digital copy. It's great. They also give you the pin. You actually are a card-carrying member of the National Association of Rocketry. There's another national association called the Tripoli Rocketry Association. They have similar rocketry level certifications, but the one that I kind of belong to is the NAR. The reason is that they actually have a chapter here in Connecticut called Cato Rocketry Club. And Cato is out in Durham, Connecticut. That's where they launch in a place called White's Field. It's actually a farm. And every, I think, 3rd Saturday of the month, they're just out there launching rockets. And so We brought ours on one of those Saturdays, and we were incredibly proud because we were the biggest rocket on the field.
Yeah.
We were like, yeah, we're ready, man. So that was good. No pressure now, though. No pressure. If you're thinking of purchasing rockets and rocket kits, we've got a list here of some of the vendors in the model rocketry class. You're looking at Estes. A new player is a player called Quest, and a company called Apogee Rockets. So these are sort of your model class rocket kits. There's another one I think you were mentioning that has some of the old rocket kits that Estes used to make. Simrock, yeah.
E-rockets.
E-rockets, yeah. So if you're looking for, like, you probably were a kid and built this one particular Mars rocket or something like that, they probably got that kit from like 1967 or something like that. So that's kind of cool. So you're like actually launching a rocket that's like a vintage one. If you're going into the high-powered rocketry category, these are the three companies that I look at. Apogee Rockets. Great thing about Apogee Rockets when you get to their website is they actually have tons of YouTube videos of how to build rockets, how to launch them safely, all of that. They are an incredible wealth of knowledge. So Apogee Rockets is fantastic. Aerotech is great for the engines. So your major big class engines is where you get them from. But the company that made the black brand, that big white monster right over there, that's Mad Cow Rocketry. So if you're really looking for a really good model, I like the Mad Cow Rocketry kits. And they're really precision rocket parts, bulkheads, electronic bays, nose cones made of fiberglass, everything is just perfectly fit, all that stuff. So it's
a US company?
It is a US company, yeah, they're all US companies. Yeah.
Where is it based, do you know?
I think it's out, not too sure.
Massachusetts?
Yeah. Estes is Denver, and Estes is out in
Penrose, Colorado.
Penrose, I'm sorry, that's right, Penrose. So they moved it from Denver
Yeah.
to Penrose because they needed more space and didn't want like a giant, pyrotechnic factory in the backyard.
Lock Precision is another good company too.
Oh, okay.
Lock Precision.
Yeah. So those are the places that where we kind of started when we were looking at our rocketry club. And so this is I'm going to close off with a little bit about our high school rocketry club that we call Space Club. I couldn't find a better name. I just pulled that one out of my butt. That was the best one. Space Club.
Space Force.
Yeah, yeah, exactly. Yeah. So that's actually a picture of our model rocket, which is great. So that's our and you have to actually name your rocket when you're doing your certification.
Yeah.
And so I couldn't find a name, and I was just pulling one out. So we called ours El Grande. That's how we worked on it. So that was good. So they actually do that like on the microphone. El Grande is now on the launch pad for very good. That was good. The rocket engines, the ones that we purchased, they do come in the same classification system. Like it's an I engine. So ours, we flew with an I-500. Okay? So it's a 500 Newton average in thrust. With an I impulse. So that was pretty impressive. What I did not know when I purchased the rocket was that there was another code, another letter that was hidden in there. And it tells you something else about the rocket. It tells you the special effects that the rocket is capable of, which I did not know when I launched it. So I just said, hey, just give me your rocket. They said, hey, here you go. Have fun. I said, thanks. This was easy. And shoved it in there. And when we launched our rocket, this was this bright blue flame.
Yeah.
And so what I didn't realize was that the extra code tells you the color of the flame.
That's white lightning.
Yeah, white lightning, yeah. Then there's the one that with the sparkies that are bad. Basically, it's just a giant ball of sparks that come out of it. That's
black sparks, black smoke and sparks.
Yeah. There's one that's just smoke.
Just smoke.
Just smoke.
Very safe.
This is totally safe.
Yeah.
In fact, I have the safety code right here, just to prove it. There we go. Okay. So, our Space Club was actually funded under a cooperative agreement with NASA. Woohoo! So we're actually using NASA money to fund our space program, which is really exciting. We recruited a couple of students from Bassick High School, Fairchild Wheeler High School, and the Aquaculture School. So mostly kids that were local, meet twice a month. And in those times, we use RockSim, which is a simulation software to help us to understand the dynamics of our rockets. We build and test rockets. We also participated in this competition called the Team America Rocket Challenge. And if you're a high school student,
Is that upstate? You don't
Yeah.
That's one you want to say?
no, that one,
You should really call it Team America.
It is, yeah.
No one, everyone forget that movie.
No, how can you forget that?
No, I
It's just it's a masterpiece.
Oh,
It is a
masterpiece of filmmaking.
Right.
So we actually can do the qualifying launch at Cato.
Oh, you can, okay.
Yeah, so as long as we get that witness, we can actually do a qualifying launch there. Team America Rocket Challenge is basically a mid-level rocket competition where you have to launch like 2 eggs to an altitude of exactly 800 feet, and then the mission can only last no more than 44 seconds. So they actually have timers. We have altimeters on our rockets to measure altitude, and so you get points deducted if you're outside of that margin. And so those are the things that happen. If you qualify, the first 100 teams that make the high scores, they will actually get invited down to, I think, in Virginia, and then they have a giant fly-off with all of these rockets. So that's pretty cool. So we participated in that. We didn't qualify. Our rocket, unfortunately, got stuck in a tree, and our August president of the Cato Rocket Club took a stick to it and tried to rip it out of the tree and rip the whole rocket apart. So, I know. So, but we taped it together, and the second one didn't quite work. Yeah, I know, it was bad. It's really bad. Yeah. So it ended up and then our parachute was destroyed, and on the way down, it actually just kind of like cargo stick right into the ground. Really awesome. And we thought and then one of the kids actually, the sister was a big fan of Hello Kitty, so we just covered it in Hello Kitty stickers and stuff. But we're comfortable in our manhood to be able to say,
Right.
Anyway, success. Yeah, you can't let a little sister down. Yeah, we can't do that. Anyway, so we did successfully launch a level run with our what's called dual deployment. So let me quickly explain what that is. So how do you get a rocket that flies really high to come back to you, so you don't have to travel miles and miles to pick it up? So this system, in the middle where you see the black band on my rocket, or our rocket, there's a little compartment, and we have an altimeter in there. And that altimeter is actually able to interrogate the environment and give us an altitude reading. So what happens is that on either side of that black band are 2 E-matches, or little wires, with black powder in little compartments, little containers, basically. And so the bottom half of the rocket, from the band down, that's the lower compartment, when the rocket reaches apogee, the altimeter senses that we're going down. And the first hint that it realizes that it's on descent, it fires the ejection charge to deploy this giant streamer. And this thing literally comes down like a rock at 1,000 feet. You can do it at 2,000 feet, you can do it at 3,000 feet, you can do it at 18,000 feet. So what happens is that we launch it, and at apogee, we drop it. Okay? And it's aerodynamically, there's some drag to it, so it's not going to come down like a real rock. But it hits a certain terminal velocity, and it's able to drop so that it's kind of aiming itself close to where we launched it. Then an altimeter finds itself at 700 feet. We can tune that altitude to anything we want, but it's nominally tuned to 700 feet. When the altimeter notices that it's at 700 feet, it takes the top nose cone, blows that off with a second pyrotechnic, and it deploys main chute. And then it comes down from 700 feet. That's how you don't have to walk 10 miles to pick up your rocket. And so that's the system. So when we did our level 1 certification, not only did we do it with the biggest rocket that we had available, with the biggest rocket engine that we had available, we even went all out and said, we're just going to do this with dual deployment too. And just said, yeah, beat that. So we're not going, yeah, that's right. So we're not going to do this half-assed. We're just going to do it all the way. So nobody had that. We were the only dual deployment system that was launched that day. But that being said, we had to do it twice, because you don't know what you don't know. And so here's the beautiful picture of the rocket at launch, and here's a picture on the rocket on descent. So let me just kind of explain what's happening here. So here's the rocket in 3 parts. There's our nose cone, there's our lower stage, and there's that E-bay with the altimeter and all that stuff. You see that little wire that's sticking out at the end of it? That little tiny container is full of black powder. It blew. Rocket blew apart in the way it was supposed to. But here's the thing. I remembered when I was using these little rockets that I would always take the parachute and wrap it around with cord and shove it inside. So I thought, hey, I do the same thing with this parachute too. I'm just going to take the parachute and wrap the cord around it and then stuff it inside. that was a bad move.
Parachute all packed up.
It's all packed up. Look at that. Isn't that cute? Just all like a little pillow.
Yeah.
Didn't deploy.
It was on.
So this dude came down from 1,300 feet and was falling. And my rocket has the dubious distinction of being the only rocket ever to almost hit launch control. So if you ever talk to anybody at Keto, talk about David Mestre and the Space Club kids, they're gonna go, oh yeah, those guys, yeah, I know them, yeah. Because this dude, literally, launch pad was probably about maybe 200 feet away. This thing drifted 200 feet from the launch pad, and it drifted in the direction of where the launch control was. And this came within about 2 feet from the guy's head. That's why you need that $5 million.
That's right.
That's why you need that $5 million, man. That's what happened. So that tip right there is actually aluminum. So,
Oh yeah, nice spear.
yeah, see, this is a dangerous hobby. So I have this this thing here, and I'm completely dejected. I'm like, going, I'm never gonna get this level 1, and nobody's gonna look at me again. And these kids right here, to their credit, they were like, we're doing this again, right? We just gotta do this again. So we packed everything up, we got everything fixed, and I had the president of the club come and help us because he actually was helping us through the entire process, and he taught everybody in the group, this is how you pack the parachute, this is what you do, and everything. So when we were going for the second launch, I popped down NASA money to buy the engine, ran up to launch control, and the range safety officer, I was grilled for like 10 minutes on what am I going to do differently.
Right.
I was like, you know,
They played a different guy.
Yeah, so-
Didn't come through.
that was, let me tell you, that was really the most uncomfortable 10 minutes I've ever had. You know, like, it's just like, this is oral arguments, go hold the crap to this here. This is like everybody's watching. And so, second time around, we got this thing to launch, and we're watching this thing at apogee, bam, pyrotechnic hits, streamer comes out, and then at 700 feet, I can't tell you the relief when we saw Main Street deploy, and this thing came out, and we were like, yeah! We just went nuts. So that was a remarkable moment, and I think that's the kind of moments that I kind of call NASA moments. You know, something like that. That's a NASA moment where you've got people at launch control, and their rocket goes. You know, or like at Jet Propulsion Laboratory, you know, dare mighty things. You know, they just finished eating their peanuts and they're like going, you know, we just landed on Mars, and you know, we just go nuts.
Yeah, right.
You know, there's this, it's incredible moments like that when young engineers get together and they're actually able to accomplish something pretty exciting. So, future, we're going to be participating in Team America Rocket Challenge again. You better believe this is going for a level 2, so we're looking to try and do the level 2. I may have to cram for that test, but you know, I'll see if I can do that. We are partnering with the University of Bridgeport, and so the nose cone section, it's not that one, but there's another nose cone that we're working with, is going to have a electronic payload inside. So we're going to do live telemetry to transmit the dynamics of the rocket. So we'll have accelerometers and gyros on board. We're going to look at high altitude ballooning. The university partnered with the Discovery Museum back in 2015, and in fact the WAS members were there to watch us as we launched our first high altitude balloon, made it up to 89,000 feet, and landed in the Hamptons. It was also, you know, it was really fun to see how the other half lives. But anyway, so we've got, and we're also looking at satellite radio communication as well. So those are some of the things that we're kind of looking at. I want to thank you. Thank you for giving me the time. I have the 6-page document on what it takes to be a level 3 certification up here, so if you want to take that. And then
It takes money.
yeah, it takes money, exactly. Yeah.
Before you do it,
Yeah.
what did you have to do to get NASA money?
What do I have to do to get NASA money? So what we did was that we submitted a proposal to NASA, and our proposal was to create a space program for kids. And so what we were intending to do was use NASA money to be able to go into a school that's on the campus of the museum next door. And kindergarten through 8th grade, we were teaching rocket science and rocket engineering. Then after that, we were going to form a high school club, and this was the high school club. So they were very interested in seeing how a partnership between a museum, a university, and an elementary school, in order for these partners to work together to actually deliver a rocket science and space science curriculum to that age group. And then we actually have to hire a company that does metrics to see, are we providing an impact? Are kids more interested in science? Are kids understanding the concepts that we're teaching? That kind of thing. The one that's really interesting for me, at least, is the high school club, because while the kindergarten through 8th grade is kind of a curriculum, we have lessons and lesson plans. The high school club, this is all, and the kids are actually driving that. So the kids built that rocket under our supervision. The kids helped with the launching. The kids participated in the Team America Rocket Challenge, and they'll be working on some of the other projects as well. And then the university, they actually have students funded under our grant to build the electronic payloads for that system. And so, hopefully in the springtime, we'll have a payload that'll be right inside that rocket. We'll have laptops on the ground with radio transmitters, and we'll be picking up the signal from that. The reason why we're kind of doing it this way is it's sort of the concept that we're kind of building a space program for young people. And so we want to go from the rockets to high-powered rockets to high-altitude balloons to space. And so that's the steps that we're kind of taking. And so eventually we'd like to be able to take the group of students that works on the Space Club to be able to get to the point where our next step is to build a satellite that actually goes into space.
The Q satellite?
Yeah, it's a CubeSat, yeah. So we're still doing that. We're still doing it, but it's a long process. It's a long process. But right now we're right now in the mode of actually looking at parts for the CubeSat. And at the museum we have the ground station, but the ground station equipment, another ham radio station can have the same kind of equipment. Steerable antennas and TS-2000.
We're gonna get all that.
It's Mike has been keeping me appraised. I mean, it's to have the dual stations in University of Bridgeport. So you'll literally have in this area 3 ground stations that are capable of communicating with the satellite and giving it command and control. And then at the museum, we have the Challenger Center. This one classroom looks like mission control for kids. And so
Cool.
And that's the kicker is to be able to retrofit that so that it actually connects to the satellite antennas, and that actually becomes a mission control where kids actually work the satellite. Yeah.
For model rocketry, is there any limitations on staging and clustering?
Yeah, I don't know. It's
That's why I took that.
I mean it's.
They stage.
They do staging.
They do staging. They do a lot of
Yeah.
stuff.
Yeah, like the D12 is like 0 is a 0.
Correct. That's right.
Yeah,
So
you
even the model class can do multi-stage rockets.
Yeah.
But I haven't seen multi-stage high power, but I imagine they're out there. Yeah. I mean, so,
How high do you think you got that thing?
that was about 1,300 feet. That was with an I engine. So I mean, if this is capable of going probably even level 2. I put an M engine in there, an N engine. I think that probably could go maybe like 3,000 feet. Yeah. The bigger engines, there are rockets that can actually go to Mach 1.
So you get the bang?
Yeah. Oh yeah.
Oh, jeez.
What class would that be?
What's that?
For Mach 1, what class? Would that be?
Probably a high level 2. Because it's a small. If it's a
So
small.
I mean, like what letter?
Oh, that's probably like an N or something. Yeah.
What's like the highest letter you can go?
Oh, yeah. Beyond that, then there aren't really kits. And then these are like guys that are actually out there machining their.
There's a guy I saw on YouTube the other day that's he's actually he's done the Falcon.
Yes.
And do you see him
Oh,
relanding
the
that?
gimbal. He's
Yes,
gimbling
yeah.
the motor.
Yeah, that is so wild.
I think it's bpa.com or something like that. So there's this. You have to see this video.
Yeah.
You got to see this video. This guy is literally building a model Falcon Heavy.
Oh yeah, I've seen this.
Yeah. You have to see. And if you've seen it, it's an awesome video.
Yeah.
The thing that makes, there are Falcon Heavy kits out there, but this Falcon Heavy
Gimbling.
has thrust vectoring,
Right.
Yeah.
gimbaled rockets on each core.
This is all solids.
Yes, this is
Yeah.
solid rocket.
This is all solids with like predetermined
Yeah.
ignition times and everything. It's
Yeah,
insane.
And it breaks into stages too. So you've got like the dragon is going to pop. I mean, it's It's really impressive.
He's got the Tesla and
Yeah, I got that little Tesla inside.
Space matchbox.
It was awesome. Yeah, man. I was looking at this thing going,
Yeah,
oh man, I thought I was hot shit.
He was so
Then I see
excited.
this.
Yeah,
He was excited too. It worked. It worked. I can't believe this.
Oh, this chip $300 chip does thrust vector in for 3 cores. I gotta need 3 of them. To
Right.
So that just the chips were like 6. That's like about
How much do you
$1,000.
think that guy's model Falcon Heavy costs?
Well, I mean, he's making these chips, you know, so he's selling for like $300. But I mean, just
So it's really just a giant rat.
it's I don't know if it's ever going to get turned into a kit, but it is an impressive system. It's an impressive system. All right, well, super.
Well, the Challenger, the space shuttle.
Yeah.
They were solid rocket boosters. They were just, these are miniature of those.
Yeah,
They
exactly.
were just a straight burn.
Once you ignited them, they
Once they ignited,
they
they
kept
were
going.
going
Yeah.
just to get it up off the ground.
Yeah, I think the most impressive thing I saw was a 1/10 scale Saturn V.
Yeah. There's one on YouTube. Check it out.
Yeah, that's probably the same one.
Yeah.
Yeah, this thing is like
Yeah, it was unbelievable.
a
It was
1/10
a
scale.
slow burn.
Yeah, oh,
How tall is that?
oh, it's about the size of the tower.
Yeah.
Yeah, it's
30
about the size of your
feet.
tower. Yeah,
Jeez.
yeah, it was
Yeah.
awesome.
And when it landed straight
Yeah.
up and down. Then
Now this is we are skirting sanity with some of this stuff. Yeah, I'll let you guys know. So like there's like one team that the guy basically strapped rockets to a snowmobile, drove the snowmobile to the launch pad, and then put the snowmobile rocket system on the launch pad and launched the snowmobile into
Oh my god.
Why?
Really?
Wait, how high did he get?
Sometimes we do stupid things.
How high did he get with
This
that
is a hobby
stuff?
where you can do really stupid things. I don't know how high to. I don't know.
certified for launch?
I think so. I think
Yeah.
somebody certified this
That's
because
a
it
little
ended up on the
disturbing
launch
to me,
pad.
honestly.
Well, on the national big high power launches, that last day or so, they had the experimental launches.
Oh, that's the experimental one right
The
there.
experimental.
Yeah.
And then they're pushed way out in the middle of the desert.
Yeah, away from people.
Yeah, way away from people. Yeah.
It's a crazy hobby. So this is, I don't think Persian Esky's ever imagined that we would be doing this.
And he's still, like I said, he's still alive.
Oh yeah.
He's goes to all the conventions. And I still got to get a story.
Yeah.
Better hurry.
Yeah.
He's not dead. He's in his 80s, but he's in good shape. So,
All right. Well, thank you. Thank you
Thank
so
you.
much.